Hey, today I'll be showing you how to use Protastructure 2018 in modeling your simple structure, running your analysis, the fundamental things you need to understand while running your structure, the basic setting, and the ideology, the analysis, the consideration in figuring out your basic model. Today we will be designing a simple two-story building. My name is Adasi Junel and I'm your instructor. Welcome back again. Before carrying out any structures like this, before carrying out a good model analysis, running your structure, having a very, very good result, there are certain things you need to consider before taking those structures. You don't just get in this, because when you're trying to like model using your grid from your plan, coming to your plan in running your grid line, sometimes you could get some obstruction. So I always recommend that you use your AutoCAD, you launch your AutoCAD software, in order for you to get your proper analysis, arrangement of your grid. So it will be very easy for you to get your right column in a good position, your grid lines and your beams location in order to get your slab, as we go through other floors. So getting this, you have to first of all do what we have to call the GA, the structural GA, which is the structural modification in AutoCAD. So let's move to AutoCAD so we can get that done. So today we'll be using this simple two-story building in getting our design. So right now, coming to AutoCAD, we are going to look at the architectural drawing. I always advise people to take a good look at the architectural design, because it is the architectural design that you are going to model to have your suitable structure, to have your structural analysis. So in all regard, you need to check the architectural design, study the column, the wall positioning. You have to look at the functionality, the way they play around the walls, because if we are going to insert our grain, our beams, the beams is going to be on the wall positioning. We're going to look at fixing our beams on the wall positioning. So in that regard, first thing I would always like to recommend that is we have to go to our wall layer. We have to go to our layer. We go to our layer right now to create a grid. No, like this in my template, I've already created a layer for the column, and I've created another layer for the beam, for the grid rather. I've created a layer for the grid and I've created a layer for the column. So in this, if you want to, so I can now close, I can now, look at changing this to have the same property. Because if you look at this currently now from the architectural, software, it's giving us S grid. So I don't want to use this. I want to provide my own grid. So in doing this, I'm just going to right click and make sure I convert this to my own grid. So it's now bear the name, bear the property on my grid, and all of them should come with the your layer. Everything you're doing should be by layer. So it should all be by layer. You see, everything you're doing here should be by layer. So you should be able to click all of them, should be by layer. So you should have the same layer properties and layer color. So in doing this, I'm going to match property. I'm going to match property to all my grid, so that when I'm going to take it back to Protastructure, it's going to reflect as an element. It's going to reflect as a grid line, showing us a proper, you know. So what we need to do is to provide our own structural element. In this regard, currently now we'll not be needing this dimension. So we're going to take this dimension up. We're going to check the properties of this dimension. This is the name, this is the layer of the dimension. So in that regard, we're going to take off this dimension so that we can view our plan very well. So you go to your quick select, go to the layer, then go to look at, where well We're going to select, this is it, this is where it is. Said okay, you can see it has highlighted the dimension. So highlighting the dimension, you can say delete. So in deleting it, you can see this is the clear plan, clear view. You can now see all, taking away the dimension, everything is now clear. And so now currently now let's take away this section. Let's take away this section. Let's make sure we make the plan very free for me to understand what we're doing. So secondly, we are going to uh, look at how we're going to set the columns. So in setting the columns, you're going to click on the rectangle. I like taking this. But before you set the column, you're going to come to a conclusion and look at what will be the size of your column. So for this size of our column, we'll be taking the exact column. Since it's a simple structure, we'll be taking the same 9 um, um, 230 columns. 230 columns. That's what the design is going to, parameter is going to give us. You can see this is our size of our column. You see, so we can use this. This in another regard, if you're using an imperial unit, this is 9 inches column. So we'll be taking this off because we won't be needing them. So we're going to click on this and copy them, copy it, and we're going to insert it every area. So advice, first of all, look at your edge. First of all, try in clicking all the edges of the building. So we'll click here, we'll have another edge here, we'll click at this joint, we'll have another here, we'll click here, we'll scroll down to this unit. Now you can see there is no grid here. There's no grid here. So we're going to provide a grid because I want a beam. If you look at this area now, it's good for me to have a grid running along this area so that we can have a grid line forming this edge. Without that, we can't have this. Meanwhile, you can click this one and say we escape, then you go back and you right click and you introduce your grid at that area. So something, I just perceived something. Now you can see a hash layer. Is making the old process looking somehow. You can see it's not making the columns active. So what we're going to do, we're going to delete this hash, that is on it. So we're going to, right click and say select similar, and we're going to delete. Look at it. This is now simple. You can now view, you can now understand your design. So this is where we're going to introduce our grid. So we'll click on this grid. Since the grid is at the center, we'll copy from this position straight up down to this position. Now you can see that this wall are not tallying. This wall are not moving the same because this is this wall is another wall. I think there's another hash member here. Let's take it off. Okay, it's now free. Okay, so these walls are not together. You can see these walls are not together. But that notwithstanding, this is the toilet. You can decide to say, okay, you want to put your beam here. This is very correct. You can say you want to do that. But because of this design, how are we doing away with this design? I don't want to cut across this. You can use a little wall to form this area. So I won't be considering this other one. This will be my secondary walls, and this will be the primary ones. So in this regard now, because why am I considering that? I'm considering the primary one because those are the ones that my structural element is bound to. So we're going to click on this, and we'll copy again. We insert at this point. Don't forget, we are inserting at the edge. So you can see we're taking it all the edge, so that we can support it. And here we're having a fill wall. So in this purpose of this video, just want to keep it simple. Some other video, I'm going to explore how we'll be introducing the fill wall, how we're going to take this into consideration. For this video, we just want to make it simple, and we're going to be considering a span of 5-meter interval. For every 5 meters, we're going to introduce our column for a proper support, So I think you should consider that when you're having your design for every 5 minutes, because the consideration, one of the factors that guides you when you're inserting your column should be you considering in a smaller structure from 3 to 4 meters, 3 to 4 meters apart, you need to consider adding your columns, adding a support to it. But for the purpose of this video, we will be considering 5, because for your smaller structure, if you consider 3 to 4, and for your bigger structure, because depending on the safe weight of the structure, depending on the load coming on the structure, when you're having structure with a high column size, depending on the load that is coming on the column, you should consider 6 meters to 7.5. So in this video, we'll be considering 5 meters. So at every 5 meters, point, we should be considering adding our column. So that is what I'm just clicking right away. So we just get it done. You can see we have a column down there. You can see this distance is quite large. So what do? We're going to add our column here. Rather, looking at this building, I'm just looking at this as a smaller structure. So we can just fit this, this could serve as a partition wall. For the purpose of this video, some other video will be exploring how we can treat this. But for the purpose of this video, we'll be considering this as partition wall. So, let's continue in adding, because if you look at this span from here down to this spot, so similar thing we have here. Just have to keep it simple, for basic understanding. We should, try to keep it simple. We should try to check the distance between here and this spot. So if we check the distance between here and this other support, we can say it's 5 meters. So 5 meters, not exceeding 6 meters. So you can still try to leave it, because what we're going to have here is, since we have 5.4 meter, what we're going to have is, the consequence of this will be we having a higher reinforcement, higher reinforcement to our beam. But that having no concern in our structure doesn't mean that the structure will be faulty or the structure will be so bad. So in that regard, we'll still, check this area. We need to support the column here, in our GA. We need to support. So taking a look at this region is okay. Now taking a look at this region is also okay. But looking at this, there's one thing I want to call to your attention. Now it's possible for me to drop my column here in line with this grid, but something happened. One thing I want you to understand, that's why I said you should take a good look at your architectural design, study it very, very well. You can see there is an opening here, and you can see there is another opening here below it, and there is a wall starting at this point, starting from this point down to this point where the staircase, where we have our staircase, and there is another opening from this dining down to the living room, and the living room down to this dining. So what we're going to, you assume there is a wall from here to this. So for you to do that, we're going to advise that you support, instead of putting your column at this middle, and you lift your wall this way and your wall this way, it would be nice for you to support our column down here and put another column down here, so that this wall will be firmly taken care of. And for the lintel that we're going to have it, because there will be an overhead beam here, at the lower region, taking care of maybe your lintel. You understand what I mean? So it's going to chain and connect to the column. So instead of putting our column here, we're going to move it down here and here. So for you to do that, we're going to highlight and we're going to move it. Don't forget, this is a normal drafting in you placing your column position. So move it down here. We'll also copy this and we're going to take it down to this point. You can see. So in that regard, now we're going to add our grid, because without grid, it is impossible for the structure to view or snap the grid. So in everywhere you're going to have your column, there is every tendency for you to have a cross grid. And everywhere you're going to have a beam, there's every tendency for you to have a parallel grid. So take that into account. So if you look at this, we have hopefully support this wall. You see, support this wall and support our structure. So look at this wall, it's now serving like a partition towards this other, area, to this other part of the structure. So in doing this, you can see that we have hopefully insert all our design and make sure all our design are hopefully sufficient right now. To keep this simple, we are going to assume this, like I say, as a partition wall, this as a partition wall, and all the toilet as a partition wall. So I'm going to stick to the basics and how we're going to support our structure. So in this, we'll hopefully support our column, bearing in mind that this area where we'll have this wall is going to be our beam area. This area is going to be our beam area, and all these areas are going to take our beam. This is where our beam is going to run, because that's where we have our our walls. Except this area where we're going to take the bale. The bale is bigger or higher. Like I said, any area when you check the distance between here, let's say this panel, we're taking this as a panel, for example. In taking this as a panel, you're going to look at this dimension between here to this spot and from here to this other spot. So if we take our dimension, you can see that from this spot down here, we're going to have 5.2. And the same regard, from here down to this grid, we're also having 7.7. So if you multiply this to this, we're going to have 40.6 meter. So 40.6 meter, this panel is large. So we're going to cut a beam across this panel and also across this panel in order for it to support the staircase, because our staircase is flowing from here at the lower region to the landing, and it's going to hang on the rest on the beam, rest on the slab. So for it to rest it on the slab, we're going to introduce a beam to take care of that stress that will be acting along that region. So in this, we are done setting our GA. So about now, we're going to take this down to our protastructure in order for we to design or run the model analysis, in getting this done. So regarding that, before we go, let's make sure we treat this grid so that we're going to work with our grid. We are going to work with our grid and make sure our grid are all in proportion, and as well as that, let's place the grid very fast. So right now you can see that we are done fixing our grid. You can see that the grid is now from 1 to 8 and 8 to H. So in this regard, don't forget, we are assuming that this is a lightweight bricks, so it's not going to have an effect on our structure. So we're going to take the impact on our slab reinforcement. That's for this video. Some other video will be showing us how we can do a proper modification when we have some walls like this. So let's stick to the the bigger guys. So right now, what we are going to do, since we are done with the GA, all this, since we have the same wall position from the ground floor to the first floor, and the same to the second floor. So there's no need for we to superimpose. Otherwise, we are supposed to superimpose, checking the column position on this area if it's going to get effect, outside the wall position. Outside the wall position. So in this regard, since it's the same, let's just save this and move to our protastructure. So in saving this, we're going to highlight all the members. We're going to highlight them, and we're going to save our W log by saving this. I just want to save only this, I just want to save only this guy separate from every of them. So I'm going to highlight all of them and save this separately by clicking this, and I'll save it to my desktop so that I can easily pick it. So I can just call it a tooth for the purpose of this design, and I'm going to say save. So in this, we're going to move straight to our protastructure right now.